All right, let's look at the function of two variables. All right, just like a function we've been dealing with, it's just going to depend on two variables instead of one. All right, so the notation is typically z is equal to f of x comma y. All right, so let's dive right into an example. It's probably just easier to go through an example. All right, let's say you have a function f of x comma y, which is defined to be 9xy plus y squared. All right, so let's evaluate f of x plus h comma y. All right, but all you really have to do is, first variable is x. So whenever you see x, you replace it with x plus h. So this is going to be equal to, all right, so you have a 9. Now I see x, so it's going to be replaced by x plus h, and y stays the same, and y stays the same. Right? So this is how you evaluate it. Right? So let's make it a little bit more complex. How would you evaluate this? Right? So I'm going to actually move this up a bit so that we have more room here. Right? So I'm going to move this up here. All right? All right, let's evaluate this. All right, so let's look at the f of x comma y plus h. All right, so every time we see y in the formula, we're going to put the y plus h in it. So it's going to be, so you have a 9. All right, x is x. All right, now I see y, so we're going to put the y plus h. All right, plus y squared. So now we're going to have to put y plus h squared instead. Right? So this is just that part, right? Minus. Then you're subtracting f of x comma y. So this is just the original function, so I'm going to just copy that exactly. Right? Then we just have to divide this whole thing by h. Right, so let's simplify. Right, so I'm going to distribute 9x to y and h. So we're going to get 9xy plus 9xh plus, right? And so if you multiply out, you're going to get y squared plus 2yh plus h squared. So this is that. And then we're subtracting 9xy plus y squared, right? I didn't need a square bracket there, so maybe I'll just change that right here. And I'm going to just put the regular parentheses. All right, and then all over h. All right, then we can cancel. There's a 9xy minus 9xy cancel out. There's a y minus y, y squared minus y squared cancel out. All right, so here are the leftover terms on top. So I'm going to collect all these guys together. But we notice that all three of them has h in it. So I'm going to pull it out. So I'm going to pull out the h here, and this one has an h there. This h squared, so I'm going to just circle the square so that I know that there's another h left over. So I put that h here, factored out. What's left is 9x from the first term. And then next one is a plus 2y. And then you have another h. So you have that. And then all over h. Right? So then you can see h divided by h cancel out. You have the same factor, common factor on top and bottom. H over h is 1. So you can cancel those. And what's left is 9x plus 2y plus h. Right? So function notation works pretty much the same. It's just that you have two variables to deal with. All right, and also domain and range is pretty much the same, but since it depends on x value and y value, domain is going to be a region instead of an interval. It's going to be a region in the xy plane. So let's look at that. All right, so if you have a function which looks like this, right? So usually square root is a troublemaker. So we have to make sure that whatever inside the square root, right, we have to make sure that it's non-negative, because if you get a negative value, then we have to deal with a complex value, an imaginary number, right? So so that's the the restriction. All right, so we have to make sure that the 25 minus x squared minus y squared is greater than or equal to 0. All right, then I'm going to maybe move these two terms over to the other side by simply adding x squared and a y squared. All right, so you have a 25 is greater than or equal to x squared plus y squared. Right? Actually, I like to rewrite it in a different way. I would like to have x squared plus y squared on the left, so it's going to be less than or equal to 25, which is 5 squared. Right? So if you pretend that this is equality, we know x squared plus y squared is equal to 5 squared. That's the equation of a circle. So if you sketch that, so equation of a circle with radius 5 and centered at the origin. So it's going to look like this. All right, so here is that, and here. So we have to draw a circle, right? So we're going to draw a circle with radius 5. Maybe I should mark that. So you have 5 here, and this is going to be negative 5 there, and positive 5, and we have a negative 5. And we have a circle that goes around like this, right? So this is a circle with radius 5. Oh, I missed it a little bit, but that's fine. All right, so this is 5 right there, right? All right, but we're talking about less than or equal to, so we're going to shade inside, right? So this is going to be the region, including the circular border, right? This is going to be the domain of the function, right? So this is the domain of this function f. Oh, actually, I didn't call that f, so I'm gonna call it f. All right, so that will be the domain. All right, the range is a little bit tricky, but if you pay attention. All right, so because of the square root, we cannot, the smallest it can be would be 0, right? We can easily achieve 0. For example, we can put 5 for x and 0 for y. Then a function becomes 0. So it's going to sit on the xy plane. So the value becomes 0, right? So you have x, the value of z is 0. That's probably the smallest, right? And the largest, right? So the biggest value you can get out of 25 minus x squared minus y squared, because you're always subtracting a non-zero value. Biggest possible value we're subtracting 0, so it's 25. So square root of 5 is going to be the largest possible value. So z value is always between 0 and 5. So that is going to be the range. So the range of this function is starting from 0, and 5 is the largest possible, right? So we have that. And if you want to sketch this, but on GeoGebra we can actually do it. So let's do that too. So if you look at the graph, and we have to do a little bit of manipulation here. So if you have 25 minus x squared minus y squared, actually I'm going to just go ahead and type it in, see if it graphs it. All right, let's open up GeoGebra. All right, GeoGebra's open, and I'm gonna just type in. Actually, I have to go to. So I'm gonna open up 3D graphics view, and I'm gonna just turn off the graphics view. All right, let's type in z is equal to square root of 25 minus x squared minus y squared. I hit enter. All right. So you can see that this is actually a hemisphere, and it's a top half of the sphere. So top hemisphere. So it looks like that. So you can see that the z value is the smallest value is you can see that it's 0, and the highest value is 5. So it looks like you know, the range that we have is correct. So the range is z is from 0 to 5. Right, and you can even see the domain if you open it up. Right, domain is going to be here. This is this circular region right here. All right, that's it. I hope that this was clear.